All right, so maybe it would be a good idea to, at the top of this worksheet, put due Friday 129. That's this Friday. All the other worksheets are due on test day, which would be due on February 4th. So just that top sheet will be due on Friday, along with the stuff we've already done. All right, worksheet 2, functions defined by integrals. This is the same stuff. There's nothing new on this sheet. It's just, it takes a little while to get used to this, so we're going to spend 2 days practicing. Work the following on notebook paper. Okay, that's not a challenge of, oh, I will write super small and I will show Mr. Wolf my microfiche style handwriting.
Do number 6 on the paper to get a lot of space.
And you do number 6 on the paper. Sure, you can do number 6 on the paper. Yes. Let's see. Which one of these should we do? I posted the answers. 5 because there's like a million parts to it.
I like that.
Let's see. 5 looks like geometry though. Right? Circles and line segments. 4 looks more conceptual.
Let's do them both.
Doing both, huh?
Yeah.
How about let's do an easy one?
Do number 2. Let's just go over the bottom.
How about we do 2, because I think 2 is a little confusing, and then 4, and then we'll see where we're at. Let's do it that way. So I'm going to say 2 and 4, and then I'll entertain suggestions after that. So number 2. 5x cubed plus 40 equals integral from c to x f of t dt. What is f of x? Part A. Find f of x. Okay. Well, we've not seen a problem quite like this. So let's ignore this 5x cubed plus 40 business. I'm not sure what that is. But I've got the integral of f, the antiderivative of f, and it's asking me for f. So what should I do to undo this antiderivative? Derivative. But like with every equation, whatever you do to one side, you have to do to the other side. Right? So back in 6th grade or 7th grade, you could add 5 to both sides. A little later, you learned you could divide both sides by 3, and then much later, you found out you could square root both sides. And now we can take the derivative of both sides. So on the right, I get 15x squared, because derivative of 40 goes away. Excuse me, that would be on the left. On the right, derivative and integral cancel each other out, and all I need to do is plug in x. And then chain rule, but derivative of x is 1, so f of x is just 15x squared. So that wasn't really a hard problem to do. Maybe it was a hard problem to figure out what they were talking about. Find the value of c. Okay, I know what f of x is. So let's kind of work the problem backwards. Let's see if this will work. So if I antiderivative that, I get 5x cubed Well, I'm not going to do plus c because I'm going to do from c to x. And then I already know that equals 5x cubed plus 40. So back to the left-hand side here. If I plug in x, oh, this is a little bit dicey here. I probably should have left that as t. Because plug in x for x, that seems a little bit weird. I get 5x cubed. If I plug in c for x, I get 5c cubed. That still equals 5x squared, 5x cubed plus 40. Five x cubes will go away. And now I can just figure out what c is. Divide both sides by -5. So c equals -2. That's a weird question. Let's jump down to number 4. H of x is the integral from 0 to x of f, where f is the graph shown. Why don't you try 4? Try it with on your own or with friends around you, and then we'll come back and go over it. So rather than me just doing it and you taking notes, why don't you try number 4, and then we'll discuss. All right, part B says, on what intervals of x is h increasing? I'm going to answer it this way. H increases when h prime is positive. And now I've justified, especially since I've said h prime is equal to f. So I'm just looking for where f is positive. So f is positive. I'm looking at my picture now between 0 and 1, 2, 3, 4, 5, 6. And that's all I need to say. In fact, I don't need to even say f is positive because I've already said that h prime and f are the same, which means I can now use those interchangeably. So some of you said when h prime is positive, some of you said when f is positive. Either one would be okay as long as you've got that statement in there somewhere. Part C, on which intervals of x is h concave up? Well, h is concave up when h double prime is positive. H double prime is f prime. And I have a picture of f, so I think I'm good to answer the question now. I mean, if you really want to sort of explain your own reasoning to yourself here, that's the thought process. H is concave up when h double prime is greater than 0. But h double prime is f prime is the slope of f. So now I'm just looking at where the slope of f is positive. So that would be, that's a little bit of an eyeball situation, isn't it? 6, 7, 8, 9. So I'm going to say 9 to 12. If you said 9.5, I guess that'd be okay too. 9 to 12. Part D. Is h of 12 positive or negative? H of 12 is the area from 0 to 12, f of t dt. So it's that total area. Well, let's just say that's A1 and A2. I can tell by looking, even without approximating or trying to guess, A1 is bigger than A2. This is what you guys were saying. And so if A1's bigger than A2, that's more positive area than there is negative area. So H of 12 is greater than 0 because A1 is greater than A2. And you can say that as long as you had A1 and A2 labeled. Right? So you can introduce new variables into your explanation as long as it's clear what those variables are.
Wouldn't it have to be absolute value grade 2?
No, because if you say area is positive. If you wanted to be, that wouldn't be wrong either if you did it this way. That would also be okay. But if you're just saying area, you mean positive. Yeah, one way to write it would be integral from 0 to 6 is greater than, now this one you would have to use absolute values, integral from 0 to 12. Because this one is negative, this one's positive. So H of 12 is positive because there's more positive area than there is negative area. And H of 12 is the area from 0 to 12. Some of it's positive, some of it's negative, but there's more positive than negative. H achieves its maximum when H prime goes from positive to negative. And we already said that H prime is equal to F, so I don't need to say it again. If you want to say it again to kind of reinforce in your brain what you're looking for, you can. But that happens at x equals 6. So, okay on that one, except maybe that part D was a little bit crazy, but probably everything else was hopefully okay. Um, 5 and 6 are really similar to the ones we've already done because it's just pictures and geometry. So back up and try number 3. And again, I think it's helpful to justify first because that helps you know what to do. So F decreases when, you could answer that question without having any information about anything. F decreases when F prime, and then let that lead you through the rest of the problem. So try that one, then we'll go over that one. Alright, so I need F prime because F is decreasing when F prime is negative. In fact, that's, I could box that up. That's my justification right there. Possibly I get some partial credit even if I don't answer anything else because that's a calculus statement. That's what I'm supposed to be looking for. It's part of my answer. So to get F prime, I'll take the derivative of both sides. So F prime is equal to the derivative of an integral